What's up, guys? Hey, we're starting our new chapter today, and we're starting on geometry, so with shapes, which is kind of exciting because geometry is quite a bit different than algebra. A couple of that stuff kind of comes into it, but usually it tends to be something a little different. It's kind of nice. And we're going to start off with area of parallelograms. And you guys have before done area of rectangles before, and that is where if you have a quadrilateral with four right angles. You could find the area of it if you knew the dimensions. Say this one was 10 units by 5 units. Area is how many square units cover something. And if this one is 10 by 1, 2, 10 by 5, so there's 10 spaces this way and 5 spaces this way, then area is exactly how many of these little squares would cover this thing. And we found out an easy way to determine that is to just take the two dimensions, the length and the width, or the base and the height, and multiply those two things together. 10 times 5, the area would be the base times the height. The base would be 10, the height would be 5. And so we would just find the area by doing 10 times 5, and 10 times 5 is 50. So if we were to count each of these squares out, we would find that it's 50 units, right? And that's what area is. Right? How many squares cover something? Think of like a lawn or something like that. But today we're going to talk about parallelograms. And a parallelogram looks kind of like a diamond, right? It's really the same thing as a rectangle, except it's kind of tilted to the side a little bit, right? And what a parallelogram means is a quadrilateral, like a rectangle, but it's got two pairs of parallel sides, right? And it does not have to have right angles like a rectangle does. And so how you find the area of a parallelogram is the exact same way you find it of a rectangle. You just need the base and the height. The base of it would be the length of this side right here, and then the height of it, the distance from the top to the bottom, right? It has to make a right angle. You cannot use the angled side of it. It's got to be straight from top to bottom. Here, I'm going to put this on the screen. If you guys need to reference this, you can pause the video here and read this to help you determine some of the vocab there. But we're going to look at our first example here. We have a parallelogram. And if I ask you to find the area of this parallelogram, you would need to find the base, which is the distance across one side, and then the distance from the top to the bottom, right? So what you would do here, and it doesn't have to be a full square, it's just going to be the full distance from here to here, right? Some people would say, oh, that's not a full square because look, that doesn't matter. It's the length of the square that matters. So we've got 1, 2, 3, 4, 5, 6 squares across the bottom, which is where we get this 6 from right here. And then the distance from the bottom to the top would go up 1, 2, 3, 4, 5, 6, 7, 8. We would travel 8 squares up, and that's where they get the 8 from there. And if you take those two together, 8 and 6, and you multiply them, you get 48. The area of this parallelogram is 48 units. And that's it. That's how you find the area of a parallelogram. So here's an example I'd like you guys to try quickly on your own. Jot down a piece of paper real quick. Okay, let's see how you did. The area of this parallelogram is found by doing base times height, right? BH. Multiply those two things together. Well, let's find out what the base is. The base is going to be across the bottom here. 1, 2, 3, 4, 5, 6 across the bottom there of this figure. The base is 6, and the height is from the bottom to top 3 high, right? So total of 3 high. So we would do 6 times 3, and the area of this would be 18 square units. We call them square units because they're squares, right? You cover it with squares. That's why we put a little 2 there. It's two-dimensional. Here's an example of one that's not on a grid, but has dimensions on it, okay? So go ahead and try this one out real quick. Pause the video if you need to. So for this one, to find the area of this, you would just do base times height. You just need those two numbers. Now this one's a little tricky because it has 3 numbers. And one of these numbers is there to trick you. Well, not necessarily trick you, but to see if you understand it. Remember, the base is the distance across the bottom of the figure. Remember, this that I have outlined in blue is the figure, okay? And the distance across the bottom of it is 4 meters. So we have 4 for the base. And then now we have a decision to make. Is the height of this figure this angle here from the bottom to the top? Or is the height of this figure from the bottom to the top at a right angle? Well, the answer is it's going to be this distance here because we want the shortest distance from the bottom to the top of this. That is the height of a figure. Okay, this is the length of a side, not necessarily its height. Okay, so we want this 16 to be the height of our figure. So we would do 16 times 4 to find the area of this figure, and 16 times 4 is 64. And in this case, these are meters. And remember, we're just determining with area how many squares cover a figure. So this is 64 squares. Square meters would cover this whole entire figure. The last one here, last example we have here is to find the missing dimension of the parallelogram. So for instance, what if I told you the base was 9 and I told you that the area was 45 square inches? Could you tell me what the height was? Well, you would set it up much like an algebraic problem, right? Where you know the area is 45, right? The A here, they tell us that it's 45, so plug that in. And that's going to be equal to the base times the height. Well, we know the base is 9, they tell us that. The distance from, from here to here, that's 9. I'm going to put a G, so it's 9. And then this is the height that we're missing, right? So essentially what we're looking at here is an equation that says 9 times something will give you 45. And if you could figure that out, then you would know what the height of the figure is, given its area and its base. Well, if you went to solve this, which you could solve a one-step equation, you would just, if h is being multiplied by 9, we would divide by 9. We'd find out that h is equal to 45 divided by 9, which is 5. The height in this is 5. So the answer to this problem, you would say the height is 5 inches. We wouldn't say squared because, remember, height is just one dimension. We just say it's 5 inches tall. That's it. And that's the area of parallelograms, guys. Good luck on your assignment today. See you later.